Hi, algebra students. So the last video we learned how to factor trinomials in the form of just x plus bx plus c, which meant that there was no leading coefficient. So remember, we used this pattern that we found of adding and multiplying, that the two numbers or the factors that we always needed to come up with would add together to get that middle term coefficient and would multiply together to get here. So that's what you've practiced. And now we're going to find out what happens if there is a coefficient in front of this x squared. So remember, part of the reason that we always knew that was going to be in the form of x something here was that this first term was x squared. So today we are going to be factoring trinomials in the form ax squared plus bx plus c. So we are going to have something in front of our x squared, and it's not always going to be a greatest common factor that can factor out. Because remember, now we did have this last example that we did on the previous page of notes. We did have a coefficient in front, right? But that 2 ended up being a greatest common factor that we could take out to the front. And so today we're going to learn what happens when you can't just factor that out as greatest common factor. So let's jump right in. So here are our steps. And actually there are going to be, we need 6 spaces here. So go ahead and split your paper down the middle, and we're just going to alternate between, there's going to be 6 different sections. So the first section, we're just going to write the steps for how to do this. So first, anytime we have something that's going to be in the ax squared plus bx plus c, the first step we're going to need to do is multiply the a value and c value. Okay, well, so what do I mean by this? So if, for example, and I'm going to put the example over here, if we had the trinomial, we're going to deal with 6x squared plus 23x plus 7. Okay, so let's take a second and look at that. Notice we've got a 6 coefficient here. So that means what we can't do is we can't just do the add and multiply here, because we can't just write out 2 sets of parentheses and put x and then x, because where's the 6x coming from? It might be 6 times 1, it might be 2 times 3. So we can't do this like the old method. We also can't factor out a 6. So 6 and 23 and 7 do not have a greatest common factor. Actually 23 and 7 are prime, so there's nothing that we can actually factor out in front to set there while we deal with just an x squared. So that's the issue here, is when you have a number in front and you can't bring out a greatest common factor. The first step we're going to do is we're going to multiply the a and the c. So I'm going to take 6, and I'm going to multiply it by 7. That's my a. So again, if you think about a, b, c, there's always going to be 3 terms. The a is whatever's in front of the x squared, and the c is always that last number by itself. So go ahead and do that. 6 times 7 we know is 42. And so I'm going to write that answer just right here. So I'm just going to say, okay, multiply that, that's 42. All right, now the next thing, now that we have done that, that sort of takes care of like what's going to go on with this 6. And so if I do that first, now I'm dealing with these numbers. So now I'm thinking of 23 and 42. And so the next step is going to just be to find factors like normal. And by like normal, I mean with the add and multiply pattern. Okay, so now we're dealing with the numbers 23. So we want to know what are 2 numbers that will add together to get 23, but that instead of multiplying together to get 7, they need to multiply together to get 42. Okay, so I'm going to think through that a second. So again, I like to write out a little list. So 23, 2 numbers that will add together to 23. I like to figure the multiplying first. So let's do 42 first. So think of all the things that will multiply together to get 42. Well, it might be 6 and 7. I mean, I know those are factors, like I've already multiplied that, but 6 plus 7 is not 23. So 6 and 7 doesn't work. What else will multiply together to get 42? Well, the next thing I think of maybe is 42 and 1, but 42 plus 1 is definitely not 23, nor is 42, well, even if they were both negative, that wouldn't work. Okay, so that's not it. The next thing I'm going to think about maybe is then 21 times 2. 21 times 2 is 42, and guess what? 21 plus 2 is also 23, so 21 and 2 work. Now, normally, and you don't have to write this down, but normally what we would do, I was looking for a scrap sheet of paper. This is all I've got. It's an old receipt. Don't judge me. And I've scribbled on it. But what we would normally do then is just put x plus 21 and x plus 2, right? But that for sure is not going to give me 6x squared. X times x is still x squared, not 6x squared. So I'm not going to do that yet. The next step that I have to do that's special and different about this particular pattern is I'm going to have to use what we call the box method. So step 3, this is the last step, is to use the box method to factor out greatest common factors. And so we're going to see what that looks like. All right, so you've used a box method actually probably to multiply in the past, and this is actually just kind of working backwards. So here's what it's going to look like. I'm going to draw a little box. Here's my box. So just a normal little square. And I'm going to split it into 4 sections, almost like a window. All right. And so what I'm going to do is I'm going to take different pieces of this original problem, and I'm going to put them in specific places in my window. So here's where it's really important that you pay attention to where you're putting things in this window. Okay. First term here. So I'm looking at my 6x squared. 6x squared, the first term in your original problem is always going to go in the top left corner. So it's always going to, I guess, if you think about like second quadrant in a coordinate plane, or it's just like the top left of the window. That's going to be your first. And then down here across from that, so if you think about like this being your first pane of your window, this is going to be the last pane, is going to be your last number. So 7 is going to go down here in this pane. Okay. Now, in these 2 panes are going to be the numbers that we figured out are the middle. So we need to represent, in this box, we need to represent this entire original problem. Here's the first term, here's the last term. Now we need 23x, but we've got 2 boxes. So how are we going to break that up? Well, it's these numbers. This is why you did this work. So 21 plus 2 is going to give me the 23, and we're going to represent them here. Now, it doesn't matter whether you put it in either box, but notice it's 23x, so we do need to put an x with both of these. So 21x, and again, you could have put 21x down here, and then we're going to put 2x. So you should be able to look at your window, your box, the box method, and this box should represent your original problem. We got 6x squared, we got the 7, and then these 2 boxes should add up to get this middle number. So this box is representing our problem. All right, now to find the factors, if you think about if this is the answer in a multiplication chart, what were the things that got multiplied together to get this? And there's a really, really simple way of finding that. What we're going to do is we're going to basically think about pushing out a greatest common factor out of all of these boxes. And we're always going to push from the right to the left. So we're always going to write an answer here. And we're always going to push our greatest common factor out upward. So greatest common factor. You don't have to write this every time. I'm just telling you what we're doing. So we're going to push a greatest common factor out both upwards and to the left. All right, so let's do that. Here's how that works. So I'm going to look first across my top row here. I'm going to zoom in a little bit so you can see this better. What do 6x squared and 21x have in common? Well, let's look at the numbers first. 6 and 21, they have a 3 in common. X squared and x, they have an x in common. That's my greatest common factor between those things. All right, now I'm going to push a greatest common factor out down here. Well, 2x and 7. Well, what do 2 and 7 have in common? Nothing. 1. They're 2. Yeah, they're both prime, and so they both have 1. And they don't even have an x in common. So 1, if there's nothing that they have in common, you're going to put 1. So my greatest common factor here is 1 that I push out. All right, now I'm going to push a greatest common factor out upwards. So I'm looking this way. Well, what do 6x squared and 2x have in common? 6 and 2 have 2 in common. X squared, and x have an x in common. So I'm going to push a 2x out as the greatest common factor. And 21 and x and 7. Well, what do they have in common? Well, 21 and 7 both have 7 in common. And 7 doesn't have an x, so they don't have an x in common. So that is my Greatest common factors up there. Now, here's the beauty and magic of this. Those are your factors. So these are the things that multiplied together to get this. 2x times 3x gives you 6x squared. 3x times 7 gives you 21x. 2x times 1 gives you 2x. And 7 times 1 gives you 7. So this is my original problem. These are the two things that multiply it. So now I just take that and I'm going to write them in parentheses. And it doesn't matter what order you put them in. And they're all positive in this case. So 2x plus 7 and 3x plus 1. And those are that's my answer. There's the two things the two binomials that'll multiply together to get this trinomial. All right, so right now you may be thinking, oh gosh, that's a lot of steps and that seems really weird. We're going to do another couple and just make sure that we feel good about these 3 steps. It's multiply the a and the c. That's the first step you have to do when you see that first coefficient. Find the factors like normal, and then we're going to use this box method to push out greatest common factors to find out what multiplied together. All right, so let's just jump right into another one. Go ahead and split those examples off. Remember, we need room for at least 4 more, so try to save yourself some room down here. All right, let's do another example together. So let's do 7x squared minus 26x minus 8. All right, and so again, I look at this first. The first thing you should always do is check for a greatest common factor. Can I factor out anything? 7 and 26 and 8, do they have anything in common that I could factor out? And unfortunately, they do not. 7 only has factors of 7 and 1. 26 does not divide by 7, neither does 8. So there's no greatest common factor that I can take out. So I know I'm in a pickle because I've got this number out here, but I remember, oh yeah, Miss Wallace told me there's 3 steps I have to take, and so I'm going to do those 3 steps. So keep in mind that this is negative 8. So the first thing we're going to do is we're going to multiply our a and our c together. And so 7 times negative 8 is negative 56. Just write that answer down below. Now I'm going to use the old add and multiply. So what will add together to get negative 26 and multiply together to get 56? Those are the two. Remember, take the sign in front of the number. So those are the 2 things I'm working with. I'm going to think about multiplication first. So negative 56. What are some things that will multiply together to get those? And again, you could go through a lot of things, 7 and 8, but those won't add to get negative 26. The answer is actually 2 times negative 28. So you may have to do, that's the thing you have to do a little bit of searching for, right? What are the 2 things that'll multiply together to get that then will add together to get negative 26? And so I'm just going to write that down just to prove it to myself. If the 28's the 28 has to be the negative one. And so multiplied together, negative 56, added together, positive 26. So those are going to be my factors. Now remember, we cannot just at this point write our parentheses and our answer. We're now on to step 3, which is the box method. So I'm going to use the box, and I'm going to give myself a little bit of room here to write my answer above and below. So I'm going to put my box over here. Box, window, whatever you want to call it. And so again, remember, we are representing the original problem in this box. So top corner is always going to be your first term. So the 7x squared goes there. The negative 8 goes down here in the corner. Remember, take the sign in front of the number. This is positive. These are negative. These 2 boxes are going to represent that middle term, and I know the numbers I'm going to use. It's 2 and 28. And so, again, it doesn't matter where you put it, but you have to put it with an x because it is negative 26x. So negative 28x and 2x are going to be my representation for that middle term. All right, now the last thing to do is to push out a greatest common factor. And I like to draw the arrows even if you don't write GCF every time, just to remind myself that I'm always pushing toward the left and I'm pushing upwards. And I'll show you why that's important here, because we especially have negatives. All right, so when we, let's do, and again, it doesn't matter which way you go first, but let's go ahead and do the top here. So we've got 7x squared and 2x. Those things only have an x in common. 7 and 2 don't have anything in common. We just share an x here. All right, now when we're pushing out this side, notice that both of these are negative. Now, it really doesn't matter that this one's negative, but what happens is if you're thinking about, again, pushing out a common factor, if this last thing, almost if you're like, okay, I'm just going to push out what they have in common, because the last thing it touches, if this number is negative, that means this factor is going to be negative. So if the one on the outside, so imagine, again, pushing a greatest common factor out here, well, what do negative 28 and 8 have in common? They have a 4 in common, but because that last thing it touches, this right here, is negative, I'm going to draw out a negative. We'll do another one here in a minute with a negative, and I'll show you. Again, it's the last thing that it touches. So -4. Then we're going to push up 7 and -28. And notice, again, this is negative. That's fine. But I'm pushing upward. So the last thing it touches is positive. So the factor is going to be positive as well. 7 and 28 both have a 7 in common. And x squared and x have an x in common. And again, it's going to be positive. And then I'm pushing out here. Well, again, I've got a negative, but the last thing it's going to touch, because I'm pushing upward, is positive. So a positive is going to come out. And so 2 and 8 have 2 in common, and it's going to be positive. They don't share an x. And so, again, those are my factors, and so I write them down. 7x plus 2, both of those are positive, but the second one is going to be x minus 4. Oh, so you can see it, x minus 4, because this one had a negative as I pushed it out. And, again, we didn't do this for the first one, but we can always check ourselves, always, because you can double distribute back out and make sure that you get your original problem. And if we do that, it is true. So 7x times x is 7x squared. And then 7 times -4 is -28x. And then plus 2x. And then if I double distribute here, I get -8. And those middle terms do come out to be the -26. And so double distributing will always help you check your answer. But those are our two factors, and that is our final answer. All right. I'm going to do another one together, and then I'm going to give you 2, and you can practice on your own. Actually, no, I lied. Let's do another one with, no, we need to do one with the greatest common factor. Okay, so let's do one more example together, and then I'll give you 2 where you can practice on your own at home. All right, so this one is going to be 6x squared minus 4x minus 16. All right, so again, you might be tempted to just jump in and do 6 times 16 and be like, boom, she told me to do A times C if I ever have a greatest common factor out here, or if I always have a coefficient out here. But we have to look for the greatest common factor first. That's why I mentioned that. So do 6, 4, and 16 have anything in common? Well, actually, they do in this case. 6, 4, and 16 all have a 2 in common. So I'm actually going to be able to set a 2 outside first. And it's very important that you do that first. Not only does it make your numbers smaller, but it also makes your answer right in the end, because one of my factors here is going to be 2. So now if I take a 2 out of all of these terms, here I would be left with 3x, because 2 times 3 is 6, minus 2x minus 8. That's the backwards of the distributive property, right? We're factoring out the greatest common factor. Okay, so now this 2 is sitting out here, and now I'm ready. I still have this a value, right? So I'm still going to have to use the old method, because the entire first coefficient did not factor out. It was only a 2. All right, so I'm going to do the a and the c value. So 3 is now my a value. -8 is my c value. So if I multiply those together, that gives me -24. And so now I'm looking what will add together to get -2 and multiply together to get -24. And so I make my little list. I think about that a while. If I think about multiplication of -24, there's only a set number of things that will multiply together to get -24. And in this case, it ends up being 4 times -6. And that might have took some trial and error. But it's because -2 is equal to 4 plus -6. So I add together to get those, multiply together to get those. I might have thought of 12 and 2, and 24 and 1, and 8 and 3, but I end up landing on the 4 and -6, just like we did the last unit. So now that I have that, I have to use my box. So the third step is to use the box. So give yourself plenty of space. And again, we're representing our original problem in the box. So now, notice again, I started this AC value once I had done the greatest common factor out. So am I going to put 6x squared in this window, or am I going to put the 3x squared? Well, it's the numbers that you multiplied, which is again why I think it's important to circle them. I'm using this. I set this 2 out here. This is not our original problem anymore. This is what we're factoring. The 2 has been set outside. So I'm going to put the 3x squared here and the -8 here. I'm only factoring this part because I know the 2's out here already. All right, and then we're going to use the -6x, and we're going to use the 4x coming from my factors here, the 2 numbers that worked for this pattern, in the other panes of the window. Now I'm ready to factor out greatest common factors, and get my answer. And remember, when I do get these answers, the thing I need to remember, and I'm going to go ahead and write it, is that there's going to be a 2 on the outside of this problem, of my final answer. So the 2 is still tags along. All right, let's do the greatest common factor. So if I factor out greatest common factor along the top, 3 and negative 6 have a 3 in common. Again, notice it touches positive last, so my answer is going to be positive. And they also have an x in common. On the bottom, 4 and negative 8 have a 4 in common. It's positive because the last thing it touches is positive. Going across the top, or going up and down, 3 and 4 don't have any numbers in common, but they do have an x in common. So these boxes have x in common. And then here we're pushing, and the last thing we're going to touch here is negative. Notice negative 6 and negative 8 have negative 2 in common, only again because it touches the negative last, and they do not have any x's in common. So my final answer is here and here with a 2 in front, x minus 2 and 3x plus 4 ends up being my final answer. And so again, that was just when we actually did have a greatest common factor that we could take out, but we do end up still having an a value here. All right, so I'm going to give you 2 problems that you can work on. Pause the video, and just to make sure that you feel good about this stuff before going into the practice. So go ahead and copy these down, and then we will check them very quickly. So 5x squared minus 14x minus 3. And then we're going to have 18x squared plus 3x minus 6. So go ahead and pause the video and give that a try. All right, so I hope you took that opportunity. I'm just going to do these again very quickly. So no common factor here. 5 times negative 3 gives me negative 15. I'm finding something that will add together, add, multiply. That ends up being negative 15 and negative 14. Those are only 1 away, so you know it's going to be the ones. Negative 15 times 1 and negative 15 plus 1 end up being my factors. In my box, I'm going to have my 5x squared here. Negative 3 should go here. Negative 15x and 1x, which you can just put as 1. And then we're going to factor out the windows. So these have x in common. I don't know why I'm going up first. These have negative 3 in common. And then going across, these have 5x in common. And these have a positive 1 in common. So my factors end up being my final answer is x minus 3 and 5x plus 1 ends up being your answer for that one. Hope you got that right. If you have any questions, make sure you email me and ask. And then this last one, I hope you checked for a greatest common factor first, because there is a greatest common factor of 3 here. So 3, 18, 3, and 6 all have 3 in common. That leaves on the inside a 6x squared plus x minus 2 that we're actually going to be factoring. Don't forget that 3 on the outside. And so I'm going to multiply my a value and my c value. That gives me negative 12. I'm looking for something that'll multiply together to get negative 12 and add together to get 1. That might feel weird until you think about the fact that negative 12 is negative 3 times 4. And if you do negative 3 plus 4, you do get 1. And so we're going to use those numbers in our box. We're only using, remember the 3 is outside, so we're using this as our original problem now to factor. And so we get 6x squared in the top pane, negative 2 in the bottom pane. We're going to use negative 3x and 4x as our other panes to factor out greatest common factors, push out greatest common factors. On the top, we get 3x. On the bottom, we get 2. It's positive because the last thing it touches is positive. These have 2x in common, and then here we get negative 1 because, again, the last thing it touches is 1, 3, or the last thing it touches is negative. 3 and 2 only have 1 in common and no x's. And so our final answer with the 3 on the outside, it's very important to keep that greatest common factor that you brought out as 3. And then we get 3x plus 2 and 2x minus 1. Again, the order of these does not matter. You could totally switch that and it would be the same thing. All right. I hope, even though that's kind of a long process, I hope these 3 steps make sense. Make sure you email me if you have questions. And that is how you factor trinomials in the form of ax squared plus bx plus c.